Today we shall discuss a very important topic which is called as alpha decay. So in this alpha decay, let us see what is going to happen here. X is considered having atomic number Z and mass number A. Whenever alpha particle is released from any parent nuclei, then you are going to get a daughter nuclei. And if you observe this daughter nuclei, its atomic number reduces by 2 units and mass number reduces by 4 units because alpha particle carries along with that atomic number 2 and mass number 4. That's the reason why atomic number reduces by 2 units and mass number reduces by 4 units. And this is called as a parent nuclei and this is called as a daughter nuclei. So this is a general example. Now let us take a live example in which we are considering radium here, whose atomic number is 88 and 228 here, and whenever alpha particle is released, you are getting a new element that is called as radon, whose atomic number reduces by 2 units and mass number reduces by 4 units. You can observe here in this equation. So 228 has become 222 and 88 has become 86. Along with that, because of release of alpha particle, whichever carries along with that atomic number 2 and mass number 4. And this type of reactions are generally exothermic reactions which releases enormous amount of heat energy. So quantity of heat energy released in this case is 4.87 million electron volts. Okay, so let us see what is going to happen here. This is just like a conservation of momentum in the case of bomb blast. So whenever you consider a bomb here, which is at rest, it blasts into two particles whose velocity is in this direction, whose velocity is in this direction. Let us consider this is a parent nuclei, this is daughter nuclei, and this is alpha particle. Along with this, a lot of amount of kinetic energy is released in this case. So now what I am going to say here is conservation of momentum takes place. Momentum before collision and momentum after collision is going to be same. Momentum before bomb blast and momentum after bomb blast is going to be same, as X is a parent nuclei which is considered to be a bomb which is at rest. So therefore total velocity of the bomb is 0, so momentum is going to be 0 after before collision, and after collision momentum is distributed along the daughter nuclei as well as alpha particle here. You all know that the relation of kinetic energy is nothing but p square by 2m. And momentum is conserved because conservation of momentum takes place here. Kinetic energy is inversely proportional to mass. Kinetic energy is inversely proportional to mass in this case. So let us see what is going to happen. So what I am going to say here is kinetic energy is inversely proportional to mass, means kinetic energy of alpha particle by kinetic energy of daughter nuclei is going to be mass of daughter nuclei and mass of alpha particle, as they are going to be inversely related. So if you add 1 on both sides, let us see what are we going to get now. Plus 1 and plus 1. So kinetic energy of alpha particle, this is after taking LCM, we will be getting Ky by Ky is equal to My plus M alpha by M alpha. One thing you should remember, whatever the kinetic energy is released here, whatever the quantity of heat energy is released, this is just because of kinetic energy of daughter nuclei plus kinetic energy of alpha particle. As these two having certain kinetic energy is here, this kinetic energy is producing a lot of exothermic radiations which are represented with letter Q. So Q is a combination of kinetic energy of daughter nuclei as well as kinetic energy of alpha particle. These two combined together is said to be heat energy release, which is given by letter Q. So what I am going to say, this is going to be Q here now. So we can write Q is nothing but it's a combination of these two. So if you replace with Q here, Q by Ky is nothing but My plus M alpha by M alpha. If you want to find out the kinetic energy of daughter nuclei, that is Ky is equal to M alpha by My plus M alpha into Q. So this is the formula with which you can find out the kinetic energy of a daughter nuclei. Once you know how much amount of energy is released in this process, and also if you know the mass number of alpha particle, it is already known to us as 4, and mass of daughter nuclei which is given as 222. That's enough for us to find out the problem here. We can find out the solution like this. So let us, the next method is how can you find out the kinetic energy of alpha particle in this case. It's very simple. You just see here now, whatever you have taken here, the same method you have to apply here also. Kinetic energy of daughter nuclei by kinetic energy of alpha particle is going to be equal to mass of alpha particle by mass of daughter nuclei. Just you can make a reciprocal of whatever you have written here now. That's it. So add 1 on both sides. So we'll be getting Ky plus K alpha by K alpha is equal to M alpha plus My by My. You all know that these two combined together is said to be Q here. So you can write Q by K alpha is equal to M alpha plus My by My. So you can find out the kinetic energy of alpha particle very simply by using this identity, which is said to be My by M alpha plus My into Q here. So these two are the formulas to find out the kinetic energy of daughter nuclei and kinetic energy of alpha particle. Now let us solve one problem based on this concept here. So what is the problem is, if kinetic energy of alpha particle is 4.78 million electron volts, then how much amount of quantity of heat is released in the above equation which is given here. So let us solve this problem very easily. I am giving the question which is displayed on the screen. You can just see this question now, which is displayed on screen. For this we are going to solve the problem now. So it's very simple that if you want to find out the quantity of heat released, it's very simple. The solution is going to be here now. So how can you find out Q if K alpha is given? So formula you are going to apply is this one, which is K alpha is nothing but My by M alpha plus My into Q. Okay, this is the formula you are going to apply here. And you have to find out what is Q. It's very simple. Q is nothing but M alpha plus My by My into kinetic energy of alpha. It's very simple. You have to apply this formula. What is M alpha given here? You can just see M alpha is nothing but mass of alpha, which is taken as 4, plus mass of daughter nuclei, which is taken as 222, by mass of daughter nuclei, which is taken as again 222, and into kinetic energy of alpha particle. It is given as 4.78 million electron volts. So therefore, you can write Q is equal to, you can just add them, 228 by 222 into 4.78. So after solving this one, we're getting 4.87 million electron volts, which is the solution here. So this type of problems can be done very easily by using this method. Thank you very much.